Good morning, this is your Stat Sensei, Mr. Spensei, and this is Death Packet on in problems 71 through 80. So, a company that produces paper towels continually monitors wet towel strength. If the mean strength for a sample drops below a specified level, the production process is halted and the machinery is inspected. Which of the following results in a type 1 error? So let's go ahead and start and go, well, HO, the claim is it um, meets strength. HA, the mean is less than strength. You know what? I'm going to rewrite that. HO, mean equals the strength. HA, mean is less than strength. All right, a type 1 error. That means I reject the truth. So in this case, I reject the truth. And this is what, all right, so I reject the truth. This was true, and that was an error. So I rejected the truth. So it was meeting strength, and now I believe this. All right. So here we go. Halting production process. Halting production process. We're definitely going to do that. So we definitely are going to halt. So we're not going to allow the production process to continue. But when sufficient customer complaints are received, no. When the towel is not within specification, no, that's not an error. We want to halt, and when it's not within specification. So it's not that halting the production process when the wet towel is in specification. So we rejected this, but it was the true. So we rejected the truth that we rejected this, but it was actually true that it was meeting strength. So our best answer choice to 71 is C. Last year, it was calculated that the recreation expenditures were 8.7% of total personal consumption. An economist believes that this percentage is going up as we move further out of the recession. Consider a hypothesis P equals 0.07 and P greater than 0.087. Which of the following choices of significance level and sample size result in the greatest power? All right, so as N goes up, power goes up. As alpha goes down, power goes up. So we want the smallest alpha, the smallest significance level, and the highest sample size. So we have alphas of 5 and alphas of 10. Um, well, I said that wrong. As alpha goes up, power goes up. I said that wrong. So we want the largest alpha. So that gets rid of this, and this gets rid of this. And then we want the largest sample size, and 30 is the largest sample size. So our answer choice is D. As alpha gets bigger, our power goes up. As the sample size gets bigger, our power goes up. 73. It is hypothesized that players lose an average of $110 an evening at blackjack table in the Las Vegas casino. A government tax collector believes the true mean is greater. So the claim is HO mu is 100. HA, we're testing whether it's greater than 100. Suppose the tax collector is correct. For a sample of n equals 100 and a significance 11.05, which of the following possible actual mean losses will the power of the test be the greatest? All right. So the farther you are away, from the claim, the better off you are. All right. So we need to be as far away from the claim of 100 as possible, but we have to be in the right direction. Well, the right direction is greater than, and the one that's farthest away in the correct direction is E. All right? Because it's easiest to reject when the farther X bar is, and that's supposed to be an S. The further these two are away, it's easier to reject as long as it's in the correct direction. In this case, we needed it to be greater than 100. Okay? All right. 74. If all variables remain constant, which of the following will not increase the power of the test? Increasing sample size. As n goes up, power goes up. So that definitely increases power. Increasing the significance level. As alpha goes up, power goes up. So that helps. Increasing the probability of a type 2 error. As type 2 error goes up, as beta goes up, as beta goes up, what happens to power? Power equals 1 minus beta. So if this gets big, then power goes down. So beta goes up, power goes down. So our answer choice to 74 is C. Which of the following is a true statement? A p-value is a conditional probability. That's a true statement. P-value is a conditional probability. Type 1 error is a conditional probability. Type 2 error is a conditional probability. And there's one other, and power is also a conditional probability for, so 75A is our best answer. 76, given that the power of a significance test against a particular alternative is 96%, which of the following is true? All right. So if power equals 0.96, remember power equals 1 minus beta, and beta is type 2. So 0.96 equals 1 minus beta. So beta equals 0.04 or 4%. And beta is type 2. So the probability of mistakenly failing to reject, because type 2 is failed to reject, is 4%. Because type 2 is failed to, beta is failed to, the probability of failing to reject is 4%. 77, consider a hypothesis test mu equals 58 versus mu greater than 58. Which of the choices will result in the greatest power of the test? All right. So if I want to increase power, n goes up, or sample size goes up, power goes up. Significance level or alpha goes up, power goes up. So I want the largest sample size and the largest alpha. Well, my alphas are 0.05 and 0.01. So we don't want the 0.01. We want the largest one. And then we want the largest sample size. And the largest sample size here is, for 77, is C. 78. In the comparison of life expectancy, two models of washing machines, the average years before breakdown in a simple random sample of one model, which is compared to that of 15 machines of a second model. The 95% confidence interval of estimate of the difference is 6 to 12. Which of the following is the most reasonable conclusion? All right. So they're basically saying we expect the difference to be between 6 and 12 years. All right. And we're talking about the difference. So we are 95% confident that the true population mean difference lies within the interval 6 and 12, that the difference in life expectancies is between 6 and 12 years. Now, they should have said true population mean and all of that, but 78, the best answer choice, is definitely E. 79, Donald believes that Western commuters drive an average of 10 miles more per day than Eastern commuters do. He selects a random sample from each group. The Western mean is 23.5 and the Eastern mean is 19.4. A 95% confidence interval to estimate the difference in the population is this. So we're 95% confident that the true population mean difference in miles traveled is somewhere between 2.5 and 5.7. Did not include the 10 miles. All right. This is the 0.05 probability. We don't talk about probability when we talk about confidence intervals. Once again, uh, we don't talk about probability. Again, that's the problem with B. Donald is likely to be correct because the difference, no. Donald is likely to be incorrect because 10 is not contained in the interval. All right. Um, that's the truth. 10 was in the interval. We think the interval is somewhere between 2.5 and 5.7. Donald's claim does not appear to be plausible. So 79 should be D. 80. Men and women were surveyed as to the ideal number of children a family should have. For 500 men, the mean was 2.95 with a standard deviation of 1.65. For women, 450, the mean was 3.05 with a standard deviation of 1.8. Assuming all assumptions are met, establish a 90% confidence interval for the difference in population size. All right. 2.95 with a standard deviation of 1.65. So x bar 1 minus x bar 2 plus or minus t star S1 divided by S1 squared over n plus S2 squared over n2. So when we plug those in, we're going to have the mean was 2.95, and for women it was 3.05. So 2.95 minus 3.05 gives me negative 10, but 2.95 minus 3.05 plus or minus, we'll come back to T star in a moment. Let's do, so we know it has to be negative 10. Well, all of them has negative 10. So that didn't help. Then we're going to have to come back and go, well, N1, what was the sample size for men? We had 500, and we had a standard deviation of 1.65. Plus, for women, we had 1.8 squared, and we had 450. All right, the only one that has it written like this is C. All right. And they actually did this as a Z test, which is probably not correct, but they did it as a Z test. But 1.65 squared over 500 plus 1.82 squared over 500. All right. All right. I appreciate you watching, and look forward to seeing you on the next one. Thank you.